So the first part of molarity and stoichiometry is that this is commonly how you see a problem. Rather than working with grams and grams of something, you usually have one of the substances or both as a solution. So it's just a stoichiometry problem with one additional step, figuring out the moles. So we have ammonium chloride and calcium hydroxide reacting according to the following unbalanced equation. So we have to balance it first of all, and then after we balance it, we'll be able to do the stoichiometry. So I took an inventory. This one's a little tricky to balance. Nothing's really matching up, but you can see that chlorine and oxygen are both, I would start probably with one of those because they're probably chlorine, because chlorine's only in one substance on both sides. So we'll put a 2 in front of the ammonium chloride. So that'll give us 2 chlorines, and that will change hydrogen. We'll have 2 nitrogens now, and 8 plus 2, which is 10 hydrogens. Okay, so let's do oxygen. So it'll give me 2 oxygens, and that changes my hydrogen to 4 plus 3, which is 7. Almost there. And we'll do nitrogen, and then hydrogen should be balanced. So I have 6 plus 4, which is 10. So it's a little trickier to balance, but stoichiometry nonetheless. So in this chemical reaction, we want to know what's the mass of calcium hydroxide needed to react with 1.5 liters of a 5 molar solution of ammonium chloride. In this problem, you have a solution rather than 2 solids. So the first step is figuring out how many moles of your ammonium chloride do you have. So this is where the molarity part comes in. Molarity is moles over liters. We have liters and molarity. Molarity times liters is equal to moles. So we're going to take our molarity, which is 5.0, multiply it by 1.5 liters, and that will give us 7.5 moles of our solution, which is the NH4Cl. So we now know how many moles of ammonium chloride we have. However, we didn't answer the question. We want to know what's the mass of calcium hydroxide, so we have to do our stoichiometry now. So this was the first part. So we need that 7.5 moles of ammonium chloride. So because we're already in moles, we can do our stoichiometry step to go from moles of ammonium chloride to moles of calcium hydroxide. So we look at our balanced chemical equation, and we have 1 mole of the calcium hydroxide for every 2 moles of the ammonium chloride. Remember, we're referring to our balanced chemical equation. This is why we need it at this point. It's asking for mass, so we'll have to do one more step. We'll have to go from moles of calcium hydroxide to grams of calcium hydroxide. So in order to figure out grams, we'll need to look at the periodic table and calculate the molar mass. So we calculate it to be 74.10 grams. We can now calculate the problem and answer the question. Notice things are canceling out. Moles of ammonium chloride cancel, and moles of calcium hydroxide cancel. Okay, so your calculator should give you 277.88. But because of sig figs, we're going to round it to 2 sig figs. You'll notice that both of the values given to us in the problem have 2 significant figures, so that's what we're going to use for to round to our answer. So it's going to become 280 grams of calcium hydroxide. Remember, if you write 2 answers like this, make sure you circle the one that you want as your final answer. So the next one, we have the same reaction. I'm just going to write my numbers in so we can refer to it. We want to know what's the mass of water produced from 2.5 liters of a 5 molar calcium hydroxide solution with an excess of ammonium chloride. So remember, the excess of ammonium chloride, all that's telling us is that we have more than enough of it. We don't have to worry about running out of it. So that's just giving us a little bit of a clue. So we have the molarity, and we have liters. Calculate moles. Now, you could have a limiting reactant problem with two solutions. It would be the exact same process as the limiting reactant problem, but we don't have that in our example today. So we have 5.0 molar solution times 2.5 liters, which will give us however many moles of calcium hydroxide. So we're going to take this, because both values have two significant figures, we're going to round the 12.5 moles of calcium hydroxide to 13 moles, just so we can keep track of our sig figs. You could use 12.5 through the entire problem and round at the end. That would be acceptable as well for our purposes. So now that we have moles of calcium hydroxide, we're going to do the exact same process we did above. 13 moles of calcium hydroxide. Since I'm in moles of calcium hydroxide, I can then go to my stoichiometry step directly. And I want to know the mass of water, which is H2O. So I have a 2 moles of H2O for every 1 mole of calcium hydroxide. And the last step is going from moles of water to grams of water. The molar mass is 18.02. You could calculate that again from the periodic table. And then we can calculate how many grams of water are produced. So with this calculation, you would end up with 470 grams of H2O. If you use 12.5 for the initial value rather than 13 and then rounded to 2, you would get 450 grams of water. Either would be accepted for this. Technically, the 450 is probably a little bit more correct. Both have two sig figs, so they're both meeting that criteria.